Moving to the identities one by one, we'll learn how to use them in factorizing a polynomial. Suppose we have 49a square plus 70ab plus 25b square. Since it's a quadratic polynomial, you may say that we can factorize it by middle term split. But if we know the identity, we can quickly do it. How to identify that whether I can use an identity here or not? To factorize this using an identity, we have to check the first square number and the last square number. I have to check whether my first term is a perfect square and the last term is also a perfect square. Yes, they are. So 49 square can be written as 7a whole square. So step 1 is to write both the square numbers as whole square. Do not fill the middle space, and this can be written as 5b whole square. Now I will check that whether 2 into 7 into 5 will give me 70. Yes, if I multiply 2 into 7a into 5b, it is giving me 70ab. So this entire thing can be written as 7a plus 5b whole square. This entire thing can be written as 7a plus 5b whole square, because my a square is 7a whole square and b square is 5b whole square. That means x square is 7a whole square, y square is 5b whole square, and 2xy is same as 70ab. So this completes the identity x plus y whole square. Now whenever we have to write the factors, we always write it in the product form and not in the exponential form. So the two factors will be 7a plus 5b into 7a plus 5b. Moving to the next, x minus y whole square. Let us factorize 4y square minus 4y plus 1. The same rule, first I will write both the terms in form of whole square. So this can be written as 2y whole square and 1 can be written as 1 square. So this is the value of x and this is my y. Putting the value of x and y, I have to check that whether 2xy is same as minus 4y. So 2y multiplied by 1 will give you 2y, that multiplied by 2 will give you minus 4y. So this can be written as 2y minus 1 whole square, and the two factors will be 2 minus 1 into 2 minus 1. Because we are factorizing, will not leave the answer in the exponential form. Coming to the next, x square minus y square, how it can be used in factorizing. The given example, 25x square upon 4 minus x square upon 9. The rule remains same. The first thing that we have to do is to write it in the form of whole squares. So 5x upon 2 whole square minus y upon 3 whole square. So my first term is this and the second term is this. The difference between the square of two numbers is given by the sum of the two numbers within the bracket multiplied by the difference between the two numbers. Simplifying it further, for adding and subtracting two fractions, the best way is to use the butterfly method. What is butterfly method? We multiply 3 with 5x and 2 with y, and the denominators to be multiplied by each other. So when I multiply them, what do I get? I get 3 into 5x, 15x, 2 into y, 2y upon 6. Similarly, this would be 15x minus 2y upon 6. Since the denominator is 6, it can be taken out. 1 upon 6 into 1 upon 6 will give you 1 upon 36 into 15x plus 2y multiplied with 15x minus 2y. So, the three factors, one being a constant 15x plus 2y and 15x minus 2y. The fourth identity rather, x plus a, x plus b, how can I use it in factorizing? Suppose two factors are given to you and you have to expand it. So, the expansion of linear factors can be done by using this identity. So, if I expand it using this identity, I can do it directly without actually multiplying two binomials. So, going by this identity, the answer would be square of the first term, sum of the two second terms, both the second terms, 8 minus 10 will give you minus 2 multiplied with the first term, and product of this and this minus 80. X square minus 2x minus 80. Since we know this identity, we can complete the question in one step. Had we not known the identity, then we would have to multiply the binomial in 3 steps and then come to our answer. So, this is the use of this fourth identity, x plus a into x plus b. Coming to the last identity of squares, that is the sum of the square of the sum of three different terms. How to factorize? How to factorize such a big expression by the use of this identity? If we had not known this identity, then we would have to resort to trial and error method by finding all the factors and then putting the values, and it would have become such a tedious work. Now, if I know this identity and by visual inspection, it is not necessary that every polynomial can be factorized using this identity, but some of them can be factorized, but we have to be very vigilant. We have to see, we have to observe. Simply by observation, we can use the identity. The question is 4x square plus 9y square plus 16z square plus 12xy minus 24yz minus 16xz. Now, what is our target? Our target would be the first three terms. First, I have to see whether the first three terms, the square terms, the variable whose variables are square, are we having the first three terms as square, or are we having three square terms in the given expression? So, like the others, we'll first write them in the form of whole squares. Next, I have to see whether x and y terms are giving me the result 12xy. 2x plus 3y is 6xy. That multiplied with 2 will give me 12xy. So, yes, this is correct. Y and z, 3y plus 4z will give me 12yz, and that multiplied by 2 will give me 24yz, but here I have minus 24. So, which term could be negative, y or z? We have to decide that, and to decide that we have to see which two terms are negative. The two negative terms are minus 24yz and minus 16xz. In both the negative terms, this z is common. The common term always makes it negative, because we've already seen that x and y are already positive. So, the common term is z, so we'll take the minus with z. The minus sign will be associated with z only, because that is only making both this term negative. I write down the remaining as it is. because they have already satisfied the identity. See, now I have found that my first term is 2x, second term is 3y, and the third term is minus 4z. So, this identity is complete, where the first term is 2x, second term is 3y, and the third term is minus 4z. So, if I have to factorize and write it as a single identity, I can write it as 2x plus 3y minus 4z whole square. Again, since I am writing the factors, I will not write them in product form. I have to write them in, I cannot write them in this exponential form. I have to write them in the product form. So, this is all about square identities. The next thing is that we'll discuss now is cubic identities. Like square identities, we have cubic identities also, because we need to factorize cubic polynomials as well along with the square polynomials. We have learned how to factorize a quadratic polynomial by middle term split, by taking common, and also by using identities. We have learned how to factorize cubic polynomials by splitting it into a linear and a quadratic. Now we'll learn how to use cubic identities to factorize, and also what are the uses of cubic identities in finding the values of large numbers. So, the first cubic identity is x plus y whole cube, which is same as x cube plus y cube plus 3xy multiplied by x plus y. That is the cube of the sum of two numbers is same as the cube of the first number, cube of the second number, plus 3 times the first number and the second number multiplied with the sum of the first and second number. Similarly, we have x minus y cube. Since y is negative, y cube will be negative because the square of a number is never negative. But if I have to cube a negative number, it will always be negative. Because of this negative y, I have minus 3xy also. The third cubic identity is x cube plus y cube plus z cube. X cube plus y cube plus z cube. See, this is different from x plus y. This is the cube of the cube of 3 different numbers summed up. That means the sum of cube of 3 different numbers is equal to the sum of 3 numbers multiplied with the square of the 3 numbers minus xy minus yz minus zx, and this minus 3xyz will be added that side. For convenience, we bring it this side to simplify our calculation. We have its implication in finding some numerical value. So, this is the third identity. The fourth identity, which is related to the third, states that in this case when we have a polynomial like this, if we have a polynomial like this and we have to factorize it, then very smartly we'll find out if x plus y plus z, if x plus y plus z, if the sum of x, y and z is 0, then what will happen? This x plus y plus z will become 0, and 0 multiplied with any number will give you 0. So, finally, my answer will rest at minus 3xyz. Obviously, if this becomes 0, the entire left hand side from here, the entire left hand side becomes 0. If the left hand side becomes 0, this will be 3xyz. So, to factorize a polynomial, if I find that all 3 numbers, the sum of all 3 numbers is 0, then obviously its factor will be 3xyz, the product of the 3 numbers multiplied by 3. Let us check them one by one. Again, as we have done in square identities, that how to factorize a given polynomial using a square identity. If it's a quadratic polynomial, we'll try the square identity. If it's a cubic polynomial, we'll try with a cubic identity. Again, given any expression, it has two terms a and b, and these are the cubes of a and b. Like we write the square numbers as whole square, here also we'll write the cubic numbers as whole cubes. So, 8a cube can be written as 2a whole cube, b cube is b whole cube. Right, this was my target. So, I can very well relate that 2a could be my x and b could be my y. So, if 2a is x and b is y, then 3xy into x plus y should give me 2a plus b multiplied with 2a plus b multiplied with 2ab, 3 into 2ab. On expanding this, I must get this result. If on expanding this, if I get this result, then this identity is completed. So, if I expand it, write the result, I'll get 12a square b plus 6ab square. Yes. So, copying this down as it is, I have checked that my identity is complete. So, this entire thing can be written in the form of a single identity 2a plus b whole cube. Again, if I write it as factors, I will write 2a plus b into 2a plus b into 2a plus b. So, this polynomial has 3 equal factors, 3 equal zeros. Similarly, we can check this also. It would be fun if I check this. 64a cube. Writing it in the form of cube, this will be 4a whole cube minus 3a whole cube. I will not write rest of the number before writing the rest of the terms. I will first check whether 3 into 4a into 3a multiplied with 4a minus 3b, not 3a, is giving me the same result or not. So, this becomes 3 4s are 12, 12 3s are 36ab multiplied with 4a minus 3b. Yes, it is giving me 144 a square b. Here it would be minus and here it would be plus. And since we have a minus outside, minus 144 a square b plus 108 ab square. So, yes, this is correct. I am getting the same value on expansion. Since I am getting the same value on expansion, this entire thing can be written as 4a minus 3b whole cube. 4a minus 3b whole cube, which can be further written as 4a minus 3b, 4a minus 3b and 4a minus 3b, 3 equal factors.